Okay, shall we start? Is it visible? Am I
Yes, sir.
audible? Okay, ma. Okay, sorry for the delay because some few students I had added, so that's why it's a delay. And yeah, before in the last class I had told you, students, before starting this, okay, those who have joined late, okay, all of you please check here that I have added Rajput textbook here. Okay, I have added in the files section. I have added a hidden mass transfer textbook by Rajput. Okay, at the end of the class, I will add Senjal also, right? Senjal and CP Gautam Raman. Okay, and my request to you all is try to buy the um, heat transfer data book by CP Gautam Raman. Of course, I will be uploading the textbook. Okay, but suppose right after 2 months or after 1 month, if you have offline classes, okay, then you are supposed to bring it for the cat 2 examination as well as the term and examination. Okay, photocopies will not be allowed for the examination, only the heat transfer data book. Okay, just like design data book. Okay, for the design of transmission systems and design of machine elements, you will be having the heat transfer data book. Okay, because it's very difficult for you to memorize those 200 or 250 formulae which you will be using for the various numerical um, in this particular subject. Okay, so all of you please buy that heat transfer data book by CP Kodan Raman. Is it fine, students? This weekend, all of you please buy it. Is it okay?
Yes, sir.
Yes, sir.
CP Kodan Raman heat transfer data book by CP Kodan Raman. Okay, please buy it. It's very important. As far as the textbook is concerned, okay, I already uploaded Rajput textbook, and at the end of the class, I will be uploading the other two textbooks, Angel and CP Kodan Raman, Heat and Mass Transfer by CP Kodan Raman, so you can refer it. Okay, as I mentioned earlier, right at the beginning of the class, you will be having so many number of numericals in CP Kodan Raman as well as in Rajput. Okay, you can go through it. Okay, so you'll be getting so many idea, especially for those who want to do some research in heat transfer, right? You can refer those examples, and then you can design certain things. Okay, so that's very important. Okay, so and that's what I said. The application of heat transfer is there in almost all. In all the engineering systems and other aspects of life also. Okay, when we talk about engineering systems, especially thermal engineering, in air conditioners we have, in refrigeration systems we have, in power plants, in car radiators, even in circuit boards, in case of laptops and all, we will be having it. Okay, so uh, we know that in air conditioners and refrigerators we have the heat exchangers, right? So, and similarly in case of power plants also, we have the boiler, we have the heat exchangers where water is converted into steam, and then the steam uh, that is impinges on the turbine blades, and then what happens is the turbine usually it is connected to a generator, so that the generator generates the electric power. Okay, so in power plants, even in nuclear power plants, we should have the idea of heat transfer. Okay, especially to avoid accidents, to avoid overheating of steam power plants and nuclear power plants. Okay, even in case of gas turbine or diesel engine power plants, we should have the idea of heat transfer, right? Similarly, car radiators, again, car radiators is one of the important thing where if it is heated that is excessively, then what happens is automatically what happens is the car won't run. Okay, if the heat transfer is not proper, then the car won't run properly. Okay, due to overheating. Okay, so and similarly the circuit boards in which what all circuit boards we use in laptops or in computer desktops. Okay, what happens is if there is no proper cooling, again what happens is you will be having some fusage of the circuits. Okay, so we should have strong knowledge of the heat transfer and how heat has to be dissipated, so that what happens is it will help in better better performance of some of the components, some of the electrical or electronic components or mechanical components. And similarly, when we want to produce power in case of power plants, okay, we should have strong knowledge about heat transfer technique. Okay, now what are all the three modes of heat transfer? We know that conduction, convection, as well as the other mode is radiation. Okay, so can anyone of you here can you say what is conduction, what is convection, what is radiation?
So conduction is transfer of heat from one place to another place.
One place to another place? Are you sure?
So from hot to cold.
From hot to cold. Well, from hot to cold, it is conduction or convection?
Convection, conduction. In conduction, it is directly transferred from one body to the other body. In convection, there's an intermediate particle that carries the heat from one object to the other object. In
Very good.
radiation, it's emitted through electromagnetic radiations and stuff.
Very good. Very good. Very good. See, simple example I can say. Right? Very simple example. Okay, so conduction, heat transfers in a body. Okay, within a boundary from one end to another end. Okay, by mean the heat is transferred from one molecule to another molecule within the body. Right? So from one end to another end. For example, if one end is exposed to high heat, okay, high temperature, so what happens is slowly the heat is transferred from one molecule to another molecule, and it is transferred to the other end. Okay, so very practical example is the fins which we have in our two wheelers. Okay, all of you have seen the fins which surround the two wheelers. How
Yes,
many
sir.
of you have seen? Almost all of you have two wheelers with you, right? You have the fins surrounding the engine cylinder. Okay, what is the
Yes,
need
sir.
for the fins, ma?
Sir, they
What's
Heat
provide
distribution.
surface area for cooling, sir.
Yeah, it provides surface area for cooling, or it conducts heat energy from the engine body. And what happens is slowly it takes the heat energy and it provides the area so that the upstream air, whenever you propel forward at a faster rate, automatically what happens is the incoming air comes in and it takes the heat energy. Okay, so from the engine cylinder body to the fin material, heat transfer is taking place by means of conduction, and from the fin material to the air by means of convection. Okay, so usually two modes of heat transfer combined together will be happening. Okay, from the material, from the engine body to the fin by means of conduction. Okay, and from the fin material to the upcoming air by means of convection. Okay, so to be in textbooks like Sasteva, basically they explain this concept of conduction by, for example, the common example which they use is a teacher has corrected papers, and what happens is he want to pass down the paper to the person who is sitting in the last bench. Okay, now you assume that there are 5 or 6 rows. Okay, so what he does is he will pass on the paper to the person who is sitting in the last bench by giving the paper to the first student. The first student passes it to the second, and then second to third, like that it goes. And finally, the person, the last person, he will be getting the answer paper. Okay, that is one way, right? The second way is either the teacher can go and hand over the paper to the student, or the student can come and take the answer paper from the teacher. Okay, and the third thing is the teacher can straight away throw the answer paper to the student and the student can get it. Now I have told you three examples. The first one is the paper is passed from the first student to the last student. The second case is the answer paper, the student comes to the teacher and he takes it, or the teacher goes to the student and he gives it. And the third one is the teacher throws away the paper so that the student takes the paper. Okay, now these three uh, things were very much related to convection, convection, and radiation. Now, any one of you, can you explain which one is is a perfect example for conduction, and perfect example for convection, and perfect example for radiation? Because in Sachdeva textbook or in others textbooks, they used to take this teacher and student example. Which one is conduction, ma?
So the first one, sir,
The first one is
conduction,
conduction. Why you say it is conduction?
because we are passing the paper from one particles to one person to
Yeah,
another.
one person to another. That is
So
within a boundary, the heat is transferred from one molecule to another molecule. So from the hot end to the cold end, the heat is transferred, slowly transferred from one molecule to another molecule. So that is conduction. Okay. The second case, as I mentioned earlier, the teacher straightly going to the student and handing over the answer paper, or the student he comes to the teacher and he receives it. So in case of convection, what happens is either the hot body, okay, comes in contact with the cold body, or the cold air comes in contact with the hot body. Okay, so I told you about two modes of heat transfer in engine fins itself. Okay, two-wheeler engine fins itself. In case of two-wheeler engine fins, what happens is the heat transfer, the which is generated due to the combustion of air fuel mixture inside the engine cylinder, it is taken by the piston. Similarly, it is also taken by the engine cylinder. Okay, so due to combustion, air fuel mixer burns. Okay, so the heat is transferred to the engine cylinder. That is by means of convection, because hot gas to the engine body, that is convection. Okay, and from the engine body to the fin material, conduction. Okay, and from the fin material to the surrounding air, again by convection. Okay, so that's why the knowledge of conduction is very much important in all the heat transfer applications, whether it is internal combustion engines, or in case of refrigerators, or in case of air conditioners. Okay, so conduction is the mode of heat transfer where within a body heat is transferred from one molecule to another molecule, and and that mode of heat transfer is said to be conduction. And thermal conductivity is one of the important parameter which defines the rate at which the material conducts. Okay, so thermal material, that is the materials which conduct, copper will be having higher thermal conductivity, aluminum will be having higher thermal conductivity. The reason for that's why the coppers are costlier, right? It conducts heat. Okay, so and similarly aluminum is also a very good conductor of heat. Okay, so it will be having higher thermal conductivity. Silver is also having a very good thermal conductivity. Okay, so thermal conductivity is one important property which we will be discussing in the next slide. Okay, and similarly, when you talk about convection is a mode of heat transfer where the hot body gives its heat energy to the surrounding cold body, and similarly, uh, suppose hot fluid can give its heat energy to the cold body. For example, two cases were there: a hot cylinder, right, or a hot body. For example, a hot vessel, right? A hot vessel, when you keep the hot vessel, okay, in the still air, after some time the temperature of the hot body reduces. Okay, this is what happens often when we do cooking also. Okay, when we cook the food, what happens is the pressure cooker or the vessel in which we cook, it will be hot, but when you keep it in still air, after some time, what happens is the temperature of the vessel reduces, maybe of half an hour or 1 hour after that it reduces. What is the reason for it? Why it reduces? Why the temperature reduces?
convection, sir.
Convection. Heat is transferred by means of convection from the hot body to the surrounding still air. We know that the second law of thermodynamics, what it states, that is heat cannot be transferred from a lower temperature body to a higher temperature body without any external aid, or in other words, heat can be easily transferred from a high temperature body to a lower temperature body without any external work. Okay, so if there is a temperature difference between two bodies, then heat is transferred from one body to another. Okay, so this is convection. Okay, either the body can be hot, okay, and the surrounding air can be cold, or in some cases, for example, when steam passes through the pipe. Okay, when the steam passes through the pipe, what happens is the pipe will be exposed to surrounding atmospheric temperature of 23 degrees, whereas the steam will be at a very high temperature. So in that case, what happens is the steam gives its heat energy to the body. Okay, so vice versa, from a hot body to the chill air, or from the hot fluid to the cold body. Okay, both the cases were there. So it involves a fluid. Okay, convection involves a fluid. Okay, conduction involves, as your friend said, it involves metals or materials. Okay, and what about radiation? Radiation is nothing but the direct heat transfer from a high temperature body to a lower temperature body without any external agency or by means of electromagnetic waves. Okay, so the sun receives, sorry, the earth receives the sun's radiation. Okay, so there is no media, right? There is no media. Okay, it's purely by means of temperature difference. Okay, so we will look into the basic laws. Okay, so the Stephen Boltzmann law for radiation, Newton's law of cooling, and similarly Fourier law of conduction. Okay, so these three laws are very very important. In module one, we will be discussing about that, and then we will be discussing about the composite systems. Okay, so basically we will be having a combination of conduction, convection in all the practical purposes. When why in all the practical problems we have, okay, we will be having a combination of conduction and convection. Just now I quoted about the internal combustion engine, where hot gas, right, due to the burning of air fuel mixer, hot gas is that is due to the combustion of air fuel mixer, you will be having the hot gas. The hot gas transfers its heat energy to the piston, and similarly the hot gas transfers its heat energy to the cylinder. Okay, so that is heat transfer from the hot gas to the cylinder is by means of convection, and from the cylinder body to the fin by means of conduction, and again from the fin material to the surrounding air is again by means of convection. All of you are able to understand the combo of convection and conduction in all the practical applications. Hello.
Yes, sir.
Okay. Another practical case is, how many of you have seen that is all of you have refrigerators in your house, right? All of you have refrigerator in your house.
Yes,
At
sir.
the backside of the
Yes, sir.
refrigerator, there are some tubular structure is there, fin like thing is there. Whether it is hot or it will be cold.
Hot.
Hot, sir.
What is the reason for it? What is the reason for the hotness of at the backside of the refrigerator?
To forcefully remove the heat.
The heat energy which is taken from the object which is placed inside the refrigerator will be given out. Okay, or in other words, the atmospheric air, right? The atmospheric air will be at a lesser temperature, but the tubes will be at a higher temperature. So the heat transfer occurs between the tube and the surrounding atmospheric air. Usually, this is what happens. Okay, suppose if the atmospheric temperature and the tube material both were at same temperature, then what happens is you won't have the heat transfer. You won't have the heat transfer, so that the refrigerant won't work properly, and similarly the air conditioner won't work properly. That's why in places like Dubai and all, during summer the temperature will be around 45 degrees. What they do is, the cooling coils outside the building, you will be having the coils. Okay, the condenser coils. Sometimes the water will be sprayed over the condenser coil, so that what happens is the refrigerant is chilled. Okay, so that it enhances the circulation of the refrigerants. I don't know, some of my friends in Dubai, they used to say it, sir, when the temperature outside, surrounding outside temperature is very hot, the condenser coil temperature and the heat transfer, we know that the heat transfer occurs more from a hot temperature body and a cold fluid. Okay, suppose if the fluid is also hotter, right, the heat transfer from the hot body to the hot air will be very much lesser, right? So if it is very much less, then what happens is it will not be effective. Okay, so that's why in places like Dubai, they used to do that in the olden days. Nowadays we have so many refrigerants. Okay, different refrigerants were used where the performance of the refrigerant is higher, and the chilling capacity or heat absorption capacity is very much higher. Okay, so these are some of the practical things. That's what I said. See, studying heat transfer, when you study heat transfer, you have to apply it for the practical purpose. That's very important. Okay, and we know that heat transfer defined. Okay, it is an energy in motion due to a temperature difference between a hot body and a cold body, and it can be easily experimentally absorbed and measured. Okay, so and when we talk about conduction, heat transfer is due to a temperature gradient in a stationary medium or media, whereas convection heat transfer occurs between a surface and a moving fluid when they are at different temperatures. Okay, so the surface and fluid, if they are at different temperature, heat transfer occurs, then it is said to be convection. And in case of radiation heat transfer occurs due to emission of energy in the form of electromagnetic waves by all bodies above absolute zero, right? So above absolute zero temperature, you will be having this heat transfer by radiation. And net radiation heat transfer occurs when there exists a temperature difference between two or more surfaces emitting radiation energy. Okay, so in radiation we will be discussing about that. And when we talk about the modes of heat transfer occurs in especially when we talk about conduction occurs in solids as well as liquids and gases. Convection usually between a solid and a fluid, and radiation usually it occurs in gases, liquids, as well as in vacuum. Okay, so that now, yeah, this is a common example. Okay, whatever, whenever, see, not only this power plants and refrigerators, internal combustion engines, air conditioners, etc. Even in cooking industry, right? The concept of heat transfer is very much important, right? The concept of heat transfer is very much important. Uh, what is the use of that copper bottom vessels here? In the television sets, advertisements were given copper bottom vessels. What is the need for it?
Sir, copper is a better conductor, sir, conductor
Yeah.
of heat.
Okay. So copper is a better conductor, so it heats up the vessel easily, so that it cooks the food faster, so that it reduces the heat energy which is needed. Right. Finally, energy, the cost of energy. We know the cost of LPG. Right. So the cost of energy is very high. Okay. So to reduce the time taken for, or to reduce the fuel consumption. Okay. Um, Usually, the copper bottom vessels are used mainly to increase the rate of heat transfer to the food which is cooked inside the vessel. Okay, and yeah, when we talk about conduction heat transfer, this is what I told you, right? You will be having the transfer of heat energy in a solid or fluid via molecular contact without bulk motion. This is very important. This bulk motion, see, often the bulk motion of the fluid is there in case of convection. Okay, see what happens in case of radiators inside cars, ma? The water will be flowing, the water will be circulating, right? Water will be circulating. A small pump is there to circulate the water from the car radiator
Yes,
to the
sir.
engine cylinder. All of you have seen it. I hope all of you have seen it. Those who have cars today, at least open your bonnet and try to see it. Okay. And then the connection from the car radiator to the engine cylinder, there will be a small pump which will be forcing, or in some cars, yeah, small belt is connected from the crankshaft to the radiator. Okay, so that what has to the pump which operates the uh, car radiator, which forces the water from the car radiator to enter into the engine cylinder. So if water is forced, okay, bulk motion of the fluid will be there. So that is convective heat transfer. Whereas in case of conductive heat transfer, the important thing which you have to understand is the transfer of energy in a solid or fluid via molecular contact without bulk motion. That is very important. By means of physical contact or by means of molecular contact, we will be having heat transfer. So lattice vibration, physical models at atomic level for prediction, and similarly in case of fluid, by means of molecular collision. Okay, see what happens is even heating, right? Even heating. Okay, when we heat water, what happens is water gets converted into vapor. We know that at a house, when we prepare coffee, the water boils at 100 degrees C. Now what happens is from the heating surface, slowly the the heat is transferred from one molecule to another molecule, so that what happens is finally the heat energy reaches the top. Okay, so when you measure, right, when you have sensors, when you measure the top surface and when you measure the bottom surface, the surface where the water is in contact to the vessel, it will be showing slightly higher temperature when compared to the top surface. Okay, so the reason for it, the heat transfer from the bottom to the top. Okay, that is also so what happens is heat is transferred within the fluid by means of molecular collisions. Okay, so in case of fluids, okay, so this is what happens in case of fluids, and this is very very important. Okay, now the heat transferred from one end to another end, let T naught be the higher temperature and T1 be the lesser temperature and T1 lesser than T naught. Okay, then the heat flux. Okay, then the heat flux Q double dash is directly proportional to minus dt by dx. Okay, minus dt by dx. Why the minus sign? Because the temperature drop occurs in the positive direction from 0 to, for example, if dx is the thickness of the material, then temperature dt is nothing but t naught minus t1. Okay, sorry, t1 minus t naught, final t1 minus t naught divided by dx. Okay, so the minus sign is given to compensate that, so that we will be getting the answer in answer positively. Okay, so the heat flux is minus dt by dx. Okay, and the property which defines, right, the property which defines the heat flux, or uh, and the property which is known as thermal conductivity, which is a thermal physical property, is it is nothing but a constant. Okay, the relation between the heat flux q and the gradient of temperature is called the constitutive relation, and this this is defined by a proportionality constant k, which is defined as the thermal conductivity k, which is equal to q divided by minus del T by del X. Okay, where del T by del X, del T is nothing but the temperature difference, del X is nothing but the thickness of the slab. Okay, for example, if it is, this is x0 and this is x1, then x1 minus x0 is nothing but the thickness, and T1 minus T0 is nothing but the temperature difference. Okay, and q equal to minus k into del T by del X, and assuming unit area. Okay, area as 1 meter squared. Usually the heat flux is given in watt per meter squared. Okay, when we consider the surface area, when we consider the length, then it will be given in watt per meter. Okay, especially for electric wires, cables, etc., it will be given in watt per meter, and whereas in case of this, it will be given in watt per meter squared. Okay, so heat flux, so this proportionality constant is said to be the thermal conductivity, which is a material property and is called as a thermophysical property. And this value changes for each and every material. And there is a very much a difference between thermal conductivity and specific heat capacity. For example, iron will be having more thermal conductivity, right? Iron is an example where you will be having more thermal conductivity, whereas water will be having lesser thermal conductivity and higher specific heat capacity. For example, you can see here the specific heat capacity of water is 4.18 kilojoule per kg Kelvin or kilojoule per kg degree C, and the specific heat capacity of iron is at room temperature is only 0.45, which indicates that water can store almost 10 times the energy that iron can per unit mass. Okay, but what happens is when we talk about the thermal conductivity of water is 0.608, whereas the thermal conductivity of iron is 80. So what you understand from this? What you understand from this? What do you understand, ma? All of you are there? Hello?
Yes, sir.
Yes, sir.
What do you understand from this? There is a difference between thermal conductivity and there is a difference between specific heat capacity. Specific heat capacity defines the manner in which the energy is stored in your body, right? So water is capable of storing more energy. That's why water is used as a coolant in most of the steam generators, nuclear reactors. Also, we use heavy water or water as a coolant, okay, which is capable of storing more heat energy. But when it comes to thermal conductivity, water will be having a very less thermal conductivity, whereas iron is having higher thermal conductivity. So depending upon the purpose, we have to select the material. Okay, if we want to heat transfer heat faster, okay, then we have to select a material which will be having higher thermal conductivity. When we want to store heat energy, then we have to select a material which will be having higher specific heat capacity. So you can see here water is a poor heat conductor relative to iron, although water is an excellent medium to store thermal energy. So don't get confused with specific capacity and thermal conductivity, or don't get confused between heat storage capacity and heat conducting capacity, okay, or thermal conductivity. Is it okay, students? Is it fine?
Yes, sir.
Okay. And look at the K values. Okay, so in relative values, when compared to silver, so silver is an excellent material which will be having higher thermal conductivity. You can see here the thermal conductivity of silver is very much higher. Okay, when compared to gold, that is a comparison value of gold to silver is 0.7, copper is 0.93, aluminum is 0.86, brass is 0.33, and other materials you can see here it is lesser, right? So now usually conductors are the materials which will be having higher thermal conductivity. You can see here silver is having very high thermal conductivity. But what happens is silver is also costlier, right? Silver is also costlier when compared to copper and aluminum. Silver is costly. That's why we don't use silver, right? We will be using copper and aluminum, okay, especially when we manufacture some components, okay, because silver is costly. But look at the thermal conductivity. Even gold is having a higher thermal conductivity when compared to brass. Okay, so only copper and aluminum will be having higher thermal conductivity when compared to gold. Okay, gold is also having very high thermal conductivity, but what happens is gold and silver were costly, so that's why we will be going for copper and aluminum. Okay, so these are all the values. Okay, comparative values of the different materials, and for non-metals, look at the value, K value. It's very lesser when compared to silver and glass. Why it is mentioned at the last? Anyone? Why in chemistry lab often you see glass, glass beakers, glass, what's that? Flask. Okay, that is even the vessels which were used for heating purposes, for heating the reactants. It's made of glass. Do you know that? What is the reason? What is the reason here?
Sir,
It
very
won't
low
break,
thermal conductivity, sir.
very low thermal conductivity, and it won't break down easily, right? It won't break down easily. Often we people think that glass it will break, but it has got very lesser thermal conductivity, and it is highly heat resistant. It is highly heat resistant. It is highly heat resistant. Okay, so that's the important thing which you have to understand. Okay, and you can see here air and water, right? So that's why air gap is always there. Even in yesterday's lab class, I asked about thermal sorry, the refrigerator door. When you take the refrigerator door, okay, outer you will be having sheet metal, and inside you will be having very low insulator which is made of asbestos or some other composite material, and in between the sheet metal, when you cut the door, you will be saying small air gap. The purpose of the air gap is the conductivity of air gap is very less. Sorry, the conductivity of air is very less, so that the heat will not be transferred from the air, especially from the sheet metal to the air, and from the air to the composite material. And similarly, the chillness will not be transferred from the composite material which is present inside to the air and to the sheet. Okay, so air acts as a insulator in between the so it's again the refrigerator door is a composite wall. Okay, you will be having air gap between the sheet metal work and the composite material which faces the inside portion of the refrigerator. Okay, so these things you have to understand. These are all the things. And similarly, when you talk about concrete, you can see here concrete, brick, snow, soil, wood. So that's why concrete and wood which is having very lesser values, okay, of thermal conductivity, we have we construct houses, right? We construct our houses using concrete or wood. Okay, so that what happens is the heat energy will not we will not be that is the heat energy will not fall inside the building. Okay, and even for limestone, okay, I think yeah, limestone is here. So look at the limestone 0.007. Earlier in villages and all, they used to construct houses with limestone. Okay, and with what's that calcium and all. The basic reason is, and they used to paint it white. What is the need for painting it white, students? Houses? Any idea? Especially outside. White is the one which reflects
White
all the
doesn't conduct heat, sir, a lot.
yeah. White reflects all the heat energy falling on it. Black absorbs all the heat energy falling on it. White reflects all the heat energy falling on it. Okay, so that's why cricketers, especially in test matches, they wear white. The main reason is they used to play the test match during daytime. Okay, and whatever the heat energy which falls on them, it is quite easily reflected, so that their body won't get heated up easily. Okay, so that's the reason white is preferred, especially in sports like cricket, where they play during the daytime, right? So that's also one of the important thing, and especially painting white is the main reason is white reflects all the radiation which falls on it. So to keep the building cooler, they used to paint it white. Okay, so these are all some of the basic things which you have to understand. In the next class, we will be discussing about thermal conductivity and similarly convective heat transfer. We will discuss about Newton's cooling law, right? And we will also discuss about the convective heat transfer coefficient values. Okay, and similarly we will yeah, these are all some of the things. And after that we will be discussing about the heat diffusion equation through your body. Okay, so in the next class we have on Thursday, right? On Thursday we will be discussing about plane wall condition. Okay, so how we apply the equation to a plane wall, and how we get the solution. Okay, so we will be discussing about that, and we will be solving some small numerical also in the next class. Okay, so my request to you student is try to uh, buy the heat transfer data book. Okay, and we will all of us we will meet next Thursday, coming Thursday, I'm sorry. Okay, with this I stop for the day.